Hello everyone, welcome to Brain Blitz Audios. In this episode of NEET preparation, we'll be dealing with previous year questions of physics in medical entrance examinations in India. The chapter that we'll be dealing with is the first chapter in the grade 11 syllabus for physics in exams. And the name of the chapter is Units and Measurements. Let's look at our first question of the chapter Units and Measurements. The speed of light, represented by c, gravitational constant g, and Planck's constant h, are taken as the fundamental units in a system of units. The dimensions of time in this new system should be one of the four options. So what basically has happened here is that they have decided to use a new system of units instead of the MLT system, the dimensions. So now we need to find time using these dimensions. How do we solve this question? Now it's actually really simple. The first thing that we do is we write time as c raised to a, g raised to b, h raised to c. So we write time as using the dimensions of the new system, c, g, and h. And we have the exponents a, b, and c for that. So the next step that we do is write the original dimensions. For time, it is m raised to 0, l raised to 0, t raised to 1. And now what we do is we write the dimensions of c. C is the speed of light, and for speed, it's lt raised to minus 1. And then whole raised to a. Let's do the same for g. And for g, it is force by mass. So m raised to minus 1, L cube, t raised to minus 2, whole raised to b. And for Planck's constant, which is ml squared t power minus 1, we put the overall exponent c. So this is our equation in the original dimensions. Now let's write each dimension with adding exponents. So for the first dimension m, now in a there is no m, so we can leave it. In b there is minus 1 raised to b, so minus 1 into b is minus b, so b m raised to minus b. And then there is m raised to c, so m raised to 1 raised to c, so 1 into c is c, so minus b plus c. So m raised to 0, l raised to 0, t raised to 1 can be written as m raised to minus b plus c. And now let's look at l. It's present in all of the three components, and in l, and in the first component for c, it is just l, so l raised to a. And then plus, since it's positive, l cube raised to b, so plus 3b. And l squared raised to c plus 2c. Now let's look at time. It's t raised to minus 1 raised to a, so t raised to minus a. T raised to minus 2 raised to b, so minus 2b. T raised to minus 1 raised to c, so minus c. Now if you notice, we've written both sides in terms of m, l, and t. So now the exponents must be equal. So therefore we can write minus b plus c is equal to 0 as equation 1. A plus 3b plus 2c equals 0 as equation 2. And minus a minus 2b minus c is equal to 0 as equation 3. So moving on from equation 1, that is minus b plus c is equal to 0, we can write c is equal to b by taking minus b to the right hand side. So minus becomes plus. So c is equal to b. The next thing that we do is we add equations 2 and 3. So a plus 3b plus 2c equal to 0. And minus a minus 2b minus c is equal to 0. So a minus a is 0. 3 minus 2 is 1, so that's b. And 2 minus 1 is again 1, so plus c. So b plus c is equal to 1. And since b is equal to c, we can replace c with b. So b plus b equals 1. So that means 2b equals 1, which leads us to b equals 1 by 2. Now, since b equals c, we can safely write c as 1 by 2. Now, let's find a. Put the values of b and c in equation 2. And so what's our equation 2? A plus 3b plus 2c is equal to 0. So a plus 3 into half plus 2 into half is equal to 0, which would give us a plus 3 by 2 plus 2 by 2 is equal to 0. That gives us a plus 5 by 2 equals 0, which gives us a is equal to minus 5 by 2. So a is minus 5 by 2, b is 1 by 2, c is 1 by 2. So the dimensions of time in the new system will be c raised to a, so that's minus 5 by 2. G raised to b, that's half. H raised to c, so that's half. So this is the dimensions. And however, in our question, g is written first. So it's convenient if we rewrite this as g raised to half, h raised to half, c raised to minus 5 by 2. By the way, writing it on both ways doesn't make any difference. So this is our answer. And if we look at our first question, we find that option A is the right option. So as you can see, A gives us the right answer. Let's move on to our next question. The dimensional formula of torque is. Now, what is torque? Torque is force times displacement. So suppose you're giving a force F from a distance d about a point, so it goes in circular motion. So the torque is force times the displacement. And when we write the dimensions, we can write the dimensions of force as mLt power minus 2, mass times acceleration, and displacement is L. So we'll write m L square t power minus 2 as the dimensions of torque, which is option A. Next question. What is the fractional error in g calculated from t is equal to 2 pi root L by g, given the fractional errors in t and L are plus x and plus or minus x and plus or minus y respectively? So how do you start solving this question? So the first thing you know is that t is equal to 2 pi root of L by g. Let's convert it into terms of g. So first thing to do is square it on both sides. So t square is equal to 4 pi square L by g. That gives g is equal to 4 pi square L by t square. Okay. So we're given the fractional errors in t and L respectively. So the fractional error is represented by absolute error divided by the original quantity. So delta t by t is plus or minus x, and delta L by L is plus or minus y. Now, how do you calculate the fractional error of something? So in this case, g will be delta g by g. Delta g by g will be equal to delta L by L plus, since time is squared, so it will be 2 times delta T by T. So this is how you represent relative error. So delta L by L is Y plus 2 times delta T by T, that's 2x. So delta G by G is equal to 2x plus Y. That means option C is the right answer. So that's the way in which you calculate. So the relative error of something can be the addition of the relative error of its components, and the components raised to some power can be written as the multiple of that power with the relative error, like this case. So now let's move on to the next question. So the question states that the density of a cube is measured by measuring its mass and length of its sides. If the maximum error in the measurement of mass and length are 4% and 3% respectively, the maximum error in the measurement of density will be 7%, 9%, 12%, 13%. So over here, the maximum error is given in percentages. So it is percentage error. And the formula for percentage error is relative error times 100. So for instance, for mass, it'll be delta M by M times 100, and that value will be equal to 4. And for the length, it'll be delta L by L times 100 will be equal to 3. So having said that, let's move on to the question. So the question is asking us to find the error in the measurement of density. How do you measure density? Density is mass divided by volume. So that means density rho will be equal to mass times volume is L cube. So over here, the percentage error of rho, which is delta rho by rho times 100, will be equal to delta M by M times 100 plus 3 into delta L by L times 100. So it doesn't matter even if it's multiplication or division, it's still addition on the relative error side. So this is the same formula regardless of multiplication or division. So delta M by M times 100, maximum error of mass, that's 4%, plus 3 times 3%. So that is 4% plus 9%. So the maximum error of density will be equal to 13%. And if you look at our options, you find that option D, 13%, is the right answer. And we got to this answer by calculating the percentage error of density. Final question. The least count of a stopwatch is 0.2 seconds. The time of 20 oscillations of a pendulum is measured to be 25 seconds. The percentage error in the measurement of time will be. So here the time for 20 oscillations is 25 seconds plus error, plus or minus error. Now this error can also be brought about by just moving 1 second more or 1 second less, a unit more or a unit less. And that, you know what that statement means is that the least count can also be considered as an error. So the time for 20 oscillations would actually be 25 seconds, 25 plus minus 0.2 seconds. So this is the time. From here, the main quantity is 25, so t is 25, and delta t, which is the absolute error, will be equal to 0.2 seconds. And the percentage error will be equal to delta t divided by t times 100. So that is 0.2 by 25 times 100. So 25 goes into 100 4 times. So the percentage error will be equal to 0.2 times 4, which is equal to 0.8. And that is found out to be option C in our question. So option C is the right answer. So the percentage error in the measurement of time for a stopwatch having least count 0.2 seconds will be 0.8 seconds. And so that concludes this episode of NEET preparation. There are a lot of questions in NEET about units and measurements. However, due to time constraints, we can't discuss all of them in a single video. So I'll attach a couple of links of our previous videos about units and measurements and other chapters of physics in our playlist. So please click the links in the description down below. And Brain Blitz Audios, as a channel in itself, is a free education content channel delivering free educational content to everyone. So if you want to be a part of our journey, please subscribe to our channel and click the notifications button in the description down below. So until then, take care, stay safe, ta-ta for now.